Hey guys, back again. Shortly after your vocab video number 1, I'm here doing this again. Well, 10 minutes later actually. So let's go over your guys' vocabulary real quick before we move on to what this video is going to be about. Okay, so again, we got weathering, which is the breaking down of rock and other substances on Earth's surface. That's the main definition for weathering here. Hopefully you guys can make that out. Erosion is the removal of rock particles by the means of water, wind and ice and gravity. Cause those sorts of things. Abrasion is the wearing away of rock by other rock particles rubbing up against it. Mechanical weathering, we're talking about things that physically break down rocks, that like either push against them or break them apart. Chemical weathering is a breaking down of rocks due to other chemicals, and these two are something we're going to be talking about in this video today. Okay, so I'm going to take a minute, I'm going to erase this. This is where I would do a harsh cut, but seeing as how Mr. Morton isn't exactly the video editor of the year, he's going to leave this in just because why not? I mean, this is what you would be dealing with if you were in class anyways, right? Alright, so today we're going to be talking about two different types of weathering, the two types that we actually care about, which are mechanical and chemical, not chemical. Okay, these are two types of weathering we're going to be talking about. You can see that there's kind of like a glare right here, and I apologize for that, but there isn't really anything I can do about that. Okay, I'm going to be talking about these two types in excruciating detail, and we'll talk about this a little bit. Okay, so some things to talk about are mechanical. What we're going to talk about is a physical, the physical breaking down of rocks in some way, shape, or form. And today we're going to be going over some examples of that. So today we'll talk about is abrasion. Okay, which is two rocks being basically rubbed against each other, whether they be moving around by wind and them knocking together or what else have you, just rubbing against each other. You guys remember in our rock lab, I had you guys taking rocks and rubbing them against each other, and that would be an example of abrasion. Obviously, out in nature, that isn't exactly the way it happens, but it kind of gives you guys an idea of how this works. Okay, but yeah. Another physical or chemical or mechanical weathering example I can give you is freezing and thawing. And the way this works is this: during the winter, or actually anytime, everybody's seen rocks or dirt or what else have you. It's not, when you see a rock, it's not completely compact together. If you look at it, it's got like cracks in it and stuff like that. Basically what freezing and thawing means is that water gets inside these cracks, and when it gets cold out, the water inside the rock or the ground will freeze. Those of you who know anything about freezing, it causes the water inside to expand, and when it expands inside the rock, it basically, picture this is your rock, and this is the water, it kind of expands or pushes it out when the water freezes, causing it to break in a physical means. So that's why it's underneath mechanical here. And I hope I'm doing a good enough job explaining that. And again, I wish I could ask you guys, and I guess I can in the poll here. So that's freezing and thawing. Okay, another one is animal actions. Okay. And so basically we're talking about things like animals digging into the ground or digging into a rock to make burrows, or making their homes inside of them, or moving them around, causing them to break, that sort of thing. Just for like burrowing purposes, so like such things like prairie dogs, burrowing owls, badgers, stuff like that. Obviously there's more out there, but these are the ones that you're more familiar with living here in North Dakota. So yeah, so animal actions is another means for physical or mechanical breakdown. Okay, and the next one is plant growth. And I wish, basically what this one means is this: you have a plant that's basically on top of a rock. what's at the bottom of every plant. So basically you have, let me see here, draw this. You have your plant, here's the dirt, then underneath you have sort of its roots, right? Well, roots, believe it or not, can get inside the cracks of rocks and just keep pushing their way through, breaking away rock or dirt, okay? That's why plant growth is an example of mechanical weathering, because it'll break apart rocks too, depending on that sort of thing, okay? And that, kiddos, is pretty much all of our mechanical weathering stuff, all of our examples, that sort of thing. And in your assignment that I gave you, you were supposed to find pictures of these and kind of explain why they are the way they are, or why this is an example of this type. Other than it's because what Google spat out, okay? The next one over here is chemical weathering. Chemical weathering, we're going to start off real quick with, we talked about chemical weathering is the breaking down of rock due to chemical means. Okay, and I gave you guys some example of chemical means. Remember, I said water, oxygen, carbon dioxide, living organisms, acid rain. Those are all examples of those sorts of things. So we're going to start talking about, which is the first one, which is acid rain. Now, every single one of you, and I used this before in a few classes, not just this one, but every single one of you, when you decide to go to either school, the grocery store, anywhere, I'm sure you guys are not walking, okay? You jump into a vehicle and then it takes you to where you need to go, okay? The burning of fossil fuels, kiddos, basically releases a lot of things into the air, okay? And it gets dissolved into our clouds, okay? And we all know that clouds essentially make rain when it, once water evaporates and precipitates out and all that sort of thing, but we'll go over that later. But basically, the burning of fossil fuels dissolves into our clouds, and basically when it rains, it causes the rain to be more acidic than, well, basic. Normally, normal water is about at 7 pH, which is technically right there in the middle. But acid rain, when it falls on rocks, it can cause them to break down and dissolve away. That sort of thing, okay? But that's an example of acid rain and how that works. And I know I didn't do the best job, and that's because we're going to be talking about this quite a bit here in the coming weeks or so, okay? The next example is carbonic acid. Okay, so carbonic acid, basically the way this works is it's CO2 that dissolves into water. And what that means is you, me, are contributing to this. What that means is we breathe out CO2 and it dissolves into water, and we should all stop breathing right now. Go ahead. Just kidding. Don't do that, please. Okay? No, but yeah, carbonic acid, again, you can get carbon dioxide from fossil fuels as well. Basically what happens is that CO2 dissolves in water, and then carbonic acid is really good at dissolving away marble and limestone. If you guys have ever seen pictures of like inside of caves, you see like these spikes coming from the ground, coming from the ground and then from the ceiling, stalactites and stalagmites. Basically, those are caused from some carbonic acid a little bit anyways, okay? But that's carbonic acid. So basically CO2, which is a chemical when dissolved in water, can cause the breakdown of rocks and minerals or the land, okay? Then the next one we're going to be talking about is living organisms, and I do not mean this one over here. I mean basically this one could be tied into this one right here. Living organisms, I'm talking about is plants again, because we're talking about, we've all seen rocks that have like algae growing on top of it, or green stuff, or even brown stuff, depending. It's another type of algae. Basically, any plant that is growing, that's roots, can produce a weak acid. that can and will slowly dissolve rock. Okay, so that so all living organisms, specifically plants, can create gases that can dissolve rocks. So that's why it's in the chemical weathering spot, and also why it's in the mechanical weathering part, because its roots will grow down in there. Okay, and the last one, the most oxygen. Oxygen is an example of chemical weathering. Why? Well, as you guys know, maybe you don't, some rocks actually have iron in it. Fe. Okay, this is the chemical symbol for iron. Fe, because it used to be called ferrium, but anyways. Rocks have iron in it. Okay, metal, that sort of thing. Those of you who know anything about anything, this iron is probably like a gray color, correct? Now, does it stay that way if you leave it outside forever and it starts to rain on it and that sort of thing? No, it starts to rust, right? It starts to get that brown color and starts to become weak, and you probably break it, that sort of thing. Basically, what happens is water gets on top of it. Well, actually, the main reason is because iron, when exposed to oxygen, will cause it to oxidize or cause it to basically bond with oxygen, which causes it to rust and get that sort of metallic or copper sort of look or brown look. Okay? And in doing so, it breaks it apart and causes the rock to become brittle, makes it an example of chemical weathering. Okay, so that pretty much wraps it up here, kiddos, for our differences between chemical weathering and mechanical weathering. You know, in class, usually I'd have a foldable to go with this. You'd have notes on one side and then a foldable on the other side. But again, due to the situation, we just can't have that happening. Okay. So after you're done watching this, make sure you respond to the poll. Make sure you guys are watching these videos, because at the end of the week here, I think I'm going to have a quiz on all this good stuff for you to go over. Okay? Well, until next time, see ya.